this video is just to debrief on the constant velocity graphs we should have found. And I just wanted to point out one thing. On these, we're always going to have distance on the y-axis and time on the x-axis. It's a consistent thing. If you had the same car, you should have found the faster car and the slower car to be very similar to each other. If you did it right, you would absolutely not have done this type of graph. This is a connect the dots graph. This is not a best fit line. I did this to show you what not to do. This green one, this black one, and this red one are all best fit. You would notice that, typically speaking, the line itself would almost never go through the actual data point. The red one does right here. That wasn't on purpose. That one just happened. But normally speaking, the lines are as close as possible, but not right on them. If data was perfect, these lines should be exactly the same if the red car was the red car, because whether or not you measure distance and even seconds in those distances, or if you measure the time it takes to go a certain second, the graphs actually should be identical. So the closer your two graphs are to being the same, the better you did at gathering your data, assuming you had the same car. If you got dramatically different things, you had probably different cars, which is possible because we did it over different days. One other thing to note, of course, the slope of this line, this more shallow slope, would be the slower car, which should have been the blue car, and then the steeper slope would be the faster car. And of course, the slope is equal to the velocity of the car, because the equation for slope is distance over time, or should probably say displacement over time. And that's the same as rise over run, because if you think about it, distance is this way, time is this way. Distance divided by time is the same thing as rise divided by run. So the slope of this line, the slope is equal to the velocity. Thank you, and like and subscribe.